Hi there. In this presentation, we are looking at Longformer, the long document transformer by Isabel Teji, Matthew Peters, and Arman Cohorn of Alan AI. Longformer is a variant of transformer that can deal with long documents. So I am going to discuss briefly what a longformer is by going to give some prerequisites and definitions. Attention mechanism in deep learning is based on the concept of directing our focus at something. Attention is one component of a network's architecture and oversees managing and quantifying the independence between the source and target sets. In the following machine translation task example, what attention will do for each word in the target sentence is map the important and relevant words from the source sentence and assign higher weight to those words. The mathematical representation of attention is given by the following formula. We split the source into key value pairs where we define the keys as attention weights to look at the source and values as the information that we will get. The scale dot product attention was chosen as a scoring function to represent the relationship between the target and attention weights and capture how aligned they are. Finally, we apply a softmax function to get the final attention weights as a probability distribution. This attention is the main component of a transformer. The downsides of this algorithm are that it runs in a quadratic time if we have a long sequence input and requires a fixed size sequence input. And to address this limitation of this classic transformer, a longformer with attention mechanism that scales linearly with sequence length has been introduced. Given the following abstract of a paper, and maybe you want to predict whether the paper gets accepted in the conference or not. Now, the classic transformer has a limited number of tokens that it can look at the same time. So what you would do in the classic transformer is you would not process this entire document. You would divide it into chunks, process each of them individually, and then maybe aggregate the predictions. But of course, the downback of this algorithm is that of this model is that the model cannot make specific connections between some words within chunks. So the goal of longformer is to just be able to put this entire document into the model at the same time and be able to make connections between words of different chunks, which brings to the understanding of the entire document. So the way to alleviate the quadratic time of classic transformers is much like you would alleviate this in a classic neural network. In classic neural network, imagine you have this multi-layer perceptron with the units in the first hidden layer and the units in the second hidden layer, and we have a weight matrix, which means every neuron in the first hidden layer is connected with every neuron in the second hidden layer, and the memory requirement here is d square. Now, how we deal with this in a classic neural network? So we go to the what is called a convolutional neural network. Convolutional neural network, what we will have is a convolutional kernel. In this case, it is just of length 3. So we just have 3 units here, and they will do the same fully connected pattern, but only over 3 units from the input layer, and then we slide the kernel over across the lower layer until you reach the end. So now we reduce the memory consumption from d squared to just like d times k, where k is the kernel size and it is constant. The same goes for longformer. So in longformer, the authors came with an idea is that you have a so-called sliding window attention, which is the same as it is in the convolutional, except that you do not have hidden units. as in the fully connected layer, and instead of the weight matrix you have the attention mechanism over the keys, queries, and values, but the idea is similar. So this is a trade-off memory for performance. Transformer-based models are unable to process long sequences due to their self-attention operation, which scales quadratically with the sequence length. To address this limitation, the authors introduced the Longformer with an attention mechanism that scales linearly with sequence length, making it easy to process documents of thousands of tokens or longer.